Welcome, UUM School of Computing students. I am Dr. Alaa Jabbar Almaliki. Today, we are analyzing the integration of big data and artificial intelligence within the criminal justice system. For decades, police work was defined by physical constraints. Detectives relied on experience and intuition while walking the beat and interviewing witnesses. Traditional forensics focuses on physical evidence gathered in a lab. However, modern crime scenes extend into the digital ether, involving terabytes of unstructured data covering years of a suspect's life. Consider the case of Julian Croft, a tech mogul found dead in a secure smart apartment. The evidence includes high-def CCTV, IoT logs, and encrypted servers. For a team of 4 analysts, processing this raw data would take 6 months, a timeline that makes a manual human investigation mathematically impossible. When human cognition reaches its limit, the justice system is mathematically forced to adopt artificial intelligence. These engines process evidence at scale, but they also introduce systemic risks into the foundation of a criminal case. This is a Celebrite interface, representing the Pathfinder AI platform. It is a pattern recognition engine designed to make mountains of data manageable for the human investigators. To maintain the integrity of evidence, forensic AI operates on an air-gapped closed network. This security measure prevents the system from referencing the live internet, which limits the risk of the model creating false information or hallucinating. In the Croft case, the AI analyzes thousands of hours of CCTV footage. It filters out all registered residents to find 17 anomalous vehicles. By cross-referencing license plates and cell pings, it narrows the search to a single black sedan registered to a man named Leo Vance. The system then uses link analysis to connect Vance to a dark web data broker. It scans offshore shell corporations receiving payments from the victim and discovers a filing name, Vance's mother. The AI extracts GPS logs from a forgotten fitness app on Vance's phone. The coordinates map a path from a nearby parking garage directly to Croft's building, placing him at the scene for 94 minutes on the night of the murder. By cross-referencing disparate datasets in milliseconds, the system replaces manual intuition with algorithmic decision support. It provides a map to a suspect that would otherwise remain hidden in the noise. The defense challenges this evidence by demanding the AI source code. This highlights the black box problem, where a proprietary algorithm gives an answer, but the specific logic used to reach that answer is hidden from the court. An audit of the training data reveals a flaw. To identify suspicious patterns, the model was fed years of historical criminal records. These datasets often contain embedded human biases, where certain zip codes or demographics are overrepresented due to past policing patterns. Because Vance lived in a zip code historically overrepresented in arrests, the AI assigned him a higher risk score before any evidence was considered. Historical prejudice was treated as a mathematical fact, putting a thumb on the scale from the start. This creates automation bias. Once the AI flagged Vance, the detectives experienced a form of tech-induced tunnel vision, focusing their investigation on confirming the machine's conclusion rather than questioning its origin. Pause for a moment. As computer science students, how would you design a mathematical audit to sanitize this training data? What techniques could you use to remove proxy variables like zip codes? Algorithmic redlining did not explicitly target Vance. Instead, the system ingested historical human prejudices and treated them as mathematical facts, a flaw that compromises the integrity of the entire investigation. This bias leads to a total legal collapse. Following the fruit of the poisonous tree doctrine, the judge suppresses all evidence found after the AI identified Vance. The case against a likely killer falls apart because the investigative tool was fundamentally tainted. Consider this. These standards include stringent data governance to audit for proxy variables, full transparency in algorithmic logic, and a mandated human in the loop to provide ethical oversight of every machine-generated lead. Forensic AI engineering requires the continuous auditing of data foundations. Beyond writing code to find a needle in a haystack, engineers have an ethical duty to prove that the haystack itself wasn't rigged from the start.